everyone, welcome to this session on using folders and layer organization in KML to manage complex visualizations in Liquid Galaxy. My name is Sahana KB, a BTech Computer Science AIML student, and this video is my submission for task 3 of GSoC 2026 prerequisite task. Now, before we dive into the how to, I want to address the why. First glance, folders may seem like a very basic feature, something you learn in your first hour of KML. But in real world, Liquid Galaxy projects, especially those that scale to thousands of data points across a cluster of 7 or more screens, folders become a backbone of your architecture. When working with immersive multi-screen system, structure is not just about readability for human eye, it directly impacts how Earth browser handles memory, how you can debug a system while standing in front of the live audience, and how much control you have over the presentation flow. In this session, I'll walk you through not only what folders are, but why they fundamentally change the way we build professional scalable Liquid Galaxy applications. Why this topic matters. Liquid Galaxy visualizations are rarely simple. If you're building a GSoC project, you aren't just placing one marker on the map. A typical project might include hundreds of place marks, multiple route lines, polygon boundaries for regions, legends, screen overlays, and interactive components that appear or disappear based on the zoom level. Now, I want you to imagine a nightmare scenario, putting all of that directly under one single document tag in KML. At first, when you have 5 or 10 points, it's fine. But as the project grows to the production level, the lack of structure becomes a catastrophic failure point. You lose control over visibility. If a judge asks you to hide the transport layer and you have a flat file, you are stuck. You struggle to isolate specific data sets. Debugging becomes a search and rescue mission, and your presentation becomes rigid. The problem isn't the data, it's the lack of organization. Folders allows us to introduce logic. They allows us to think in layers. That shifts from element based thinking to layer based thinking is what separates a beginner from a professional developer. The real problem, flat KML structure is a technical depth of GIS world. In a flat structure, every place marks, polygons, and line strings sits directly under the document. Let's break down why this is a real problem. There is no semantic meaning. Your code doesn't tell a story. It's just a list. This creates confusion. Meanwhile, when you grow from 20 to 500 elements, your XML file becomes a wall of text that no human can freeze. This is the scalability issue. In debugging taxes, if one element misbehaves, says a polygon is flickering, you have to scan thousands of lines to find it. In presentation rigidity, an immersive environment like Liquid Galaxy, you need theoretical control. You need to be able to dim the lights on the data sets to highlight another. In a production environment, structure is your best friend. Flat KML might work as a quick demo on your laptop, but structured KML is the only way to survive a multi screen deployment. What is a folder in KML? Technically, a folder is a container element, but I want you to think about it conceptually. Folders introduce hierarchy into geographic visualization. In computing, hierarchy equals meaning. When you group elements inside a folder called tourist spots, you aren't just grouping points, you're defining the semantic intent of that data. Folders give you logical grouping and visibility control at the group level. They act like directories in your operating system. We don't put every file on your computer on the desktop. We use folders to categorize. In KML folders, introduce modular thinking. If you want to build a system that can handle the complexity of a smart city visualization, you have to start thinking in modules. Basic KML structure. Uh, KML is a hierarchical by design. The top level is the document. Inside that document, we nest our folders. Inside those folders, we place our features, the place marks, polygons, line strings, and etc. This nesting creates a clarity that resembles object oriented design. You are grouping related responsibilities together. When someone else, perhaps a mentor or a teammate, reads your KML file, they should immediately understand your architecture. Structured KML is effectively self documenting. It communicates your design decisions through its very shape. In the collaborative world of Liquid Galaxy development, this is a vital skill. Flat versus structured KML. Let's visualize the difference. In flat KML, everything is a sibling. There is no separation between a root, a marker, or a UI element. If you want to change the style of your roots, you have to hunt them down individually. But here in structured KML, however, creates a modular control. You can collapse entire section in your editor. You can toggle entire layers in the Google Earth slide bar. When you are updating a feature, you know exactly where to go. When you are disabling a data set, you disable a one folder instead of hundreds of lines. Structured KML supports growth, flat KML resists it. That difference becomes painfully visible the second you try to add new feature in an old project. Layer based thinking. Before you even start coding, you should be designing your layers. Layer based thinking means separating concerns. For instance, the base layer, your static map content, the data layer, your actual geographic story you are telling, uh, UI layer, your legends and screen overlays, interactive layer, the elements that only show up when the user clicks on something or something. When you assign elements to these conceptual layers, your folder structure becomes intentional rather than accidental. This improves maintainability, readability, and perform planning. Layer things transforms KML from a basic markup file into a genuine system design. Example folder layout. Let's look at the real world example. Inside your document, you create a specific folder: base map, traffic, tourist spots, routes, and legends. Why is this layout superior? Because during a live demo in Liquid Galaxy, it gives your directors power. You can turn off the traffic data to focus on the specific building. You can hide the overlays to let the user see the satellite image or very clearly. Instead of editing code to the fly, you are controlling visibility logically. Structure enables narrative control, and narrative is what makes Liquid Galaxy demo successful. Visibility, visibility control. Visibility control is where folders transition from a organizational tool to a functional UI component. In KML, the visibility tag is binary 1 or 0. but its impact is conceptual when applied to a folder. Think about the user experience on a Liquid Galaxy. If you have 200 place marks on the screen, the visual noise is defaming. By using folder level visibility, you can implement what I call uh, thematic shifting. You can have all your data loaded into memories but kept invisible. As the presenter speaks about public transport, you toggle the transport folder, instantly the screen updates. This is much more efficient than loading separate KML files, which causes a flicker or a loading lag on the slave screens. It allows for a seamless semantic transition that keeps the audience immersed in the environment without technical interruptions. Organizing by geography. When you move into large scale GIS projects, we have to talk about geographic partitioning. If you are visualizing data for the entire country of Spain, you can't simply have one folder for hospitals. You need a nested hierarchy: Spain, regions, cities, and hospitals. Why? Because Liquid Galaxy is a high resolution environment. Users will zoom from the global view down to the street level view. By organizing geographically, you allow the system to handle spatial logic. You can set specific folders to only become active when the camera is over at the certain coordinate. This prevents the slide bar bloat, where a user has to scroll through 1,000 items to find one of their current view. It makes the data discoverable and geographically intuitive, which is the primary goal of any Liquid Galaxy application. Organizing by data types. Now, let's look at the alternative: organizing by data types. This is the developer view. In this model, your folders are categorized by geometry they contain: the polygons folder, the line strings folder, and the points folder. While the geographic approach is good for the users, the data type approach is superior for styling. In KMLs, you often use style maps and shared styles. If all your highways are in one folder, you can apply a global style change to that entire folder's content much more easily. During the development phase, this organization saves you hours of work. If the client says make all the boundaries line 20% transparent, and your file is organized by data types, you edit one style block at the top of your folder. If it's unorganized, you are editing 100 individual lines of code. This is about working smarter, not harder. UI and legend separation. This is a critical point for Liquid Galaxy specifically. We use screen overlays to show legends and logos and info boxes. These are 2D elements rendered on the top of 3D globe. If you mix your screen overlay code inside a folder of geographic place marks, you are breaking the separation of concerns. I always recommend a dedicated UI elements folder. This folder should sit at the very top or the very bottom of your document. This allows you to lock the UI. Even if you're dynamically swapping out geographic data layers during a presentation, your UI remains stable. It also makes it easier for the other developers to find the graphics of the project without digging through latitudes and longitude coordinates. It's about keeping the map separated from the interface. Performance benefit. Let's talk about the slaves, the multiple instance of Google Earth running on the Liquid Galaxy cluster. Every time you change something on the master, that change is broadcasted. A structured KML file is easier for the KML phraser to index. When elements are logically grouped, the engine can optimize the rendering pipeline. For instance, if an entire folder is marked as individual, the rendering engine can often skip the draw call for every object inside it. In a project with 1,000 points, this is the difference between a smooth 60 frame per seconds experience and a stuttering, laggy mess. Organization is performance by reducing the overhead of the phasers. You ensure that the multiple screen synchronization remains frame perfect. Multiple screen LG consideration. On the Liquid Galaxy, you aren't designing for one screen, you are designing for a panoramic field of view. Visual clutter on one screen can distract from a focal point of screen 5. Folders allow you to perform visual balancing. You can organize your data so that certain layers only populate specific areas of panoramic view. It also helps with the Liquid Galaxy controller apps. Most controller phrase the KML tree to build their touch screen interface. If your KML is mess, the touchscreen controller will be a mess too. Clean folder structure automatically generates a clean, usable interface for the person operating the Liquid Galaxy, ensuring the immersive experience isn't ruined by the confusing control panel. Combining folders with regions. The most advanced use of folders is nesting them within regions. A region defines a visibility box based on latitude and coordinates. When you put a folder inside a region, the entire folder and the everything in it uh, becomes LOD, which means level of details active. This means you can fly closer to the city details folder activates. As you pull back to space, it deactivates. This is the professional way to handle big data on Liquid Galaxy. It prevents the system from trying to render every street lamp in New York while you're looking at entire Earth. Folders provide the container that makes this regional logic possible and more importantly readable for the developer. Common mistakes. To avoid failure, we must recognize the common traps. The conceptual mistake is overnesting, creating folders so deep that you lose track of parent child relationships. Another is crazy naming. If you see a folder named Untitled Folder 2, I don't know what I don't know what's on it, if that's critical data or a backup or something. The biggest mistake, however, is a visibility conflict. Setting a child to be visible, but the parent folder to be invisible. The child will not show up, and you will spend a lot of hours wondering why this code isn't working. Understanding the inheritance of the folder structure is key to avoid these basic but time consuming errors. Best practices. My golden rules for KML organizations are Meaningful naming. Every folder name should describe the data and the source, and you should know by reading those folders what is inside that folder. Shallow hierarchy. Try not to go more than three or more levels deep. Consistency. If you group by geography in one section, don't switch to grouping by data types in the next. The toggle test, always check if the project still makes sense when half the folders are turned off. Design your KML as if the next person who has to edit it is a violent psychopath who knows where you live. Keep it clean, keep it logical. Example use case, imagine um, a tourism app for Liquid Galaxy. We have a narrative structure. In folder 1, the past, the B and W overlays of old maps. In folder 2, the present, 3D buildings and current IO, current POIS. Folder 3, the future, planned developments. By simply clicking through these folders in order, the presenter can take the audience in a journey through time. This is the progressive narrative model. You aren't just showing a map, you are using the folder structure to script a movie like experience in Liquid Galaxy. Benefits of proper organization. Um, The cumulative benefits of what we will discuss today are clear. You get easier debugging because your code is modular, and you get scalability because your architecture is ready for more data. You get professional grade performance because the system isn't overtaxed. But most importantly, you get a production ready asset. In GSoC and Liquid Galaxy community, we value code that others can build upon. A well organized KML file uh, is a contribution to the ecosystem, not just one off script. It reflects a high level of engineering discipline. Coming to the summary part, to conclude, we have journeyed through the architectural world of KML. We have seen how folders are the secret to managing the immense complexity in Liquid Galaxy projects. We have covered the danger of flat structures and the technical depth they create, the power of layer based thinking to separate concerns, how folders improve rendering performance on multi screen clusters, and how to use hierarchy to tell a more compelling interactive story. Folders might seem like a simple concept, but as we have seen, they are the architectural foundation of professional visualization. As you go forward with your project, remember structure is not just a afterthought, it is a project. Thank you for watching. Hope this session helped you understand uh, that folders are not just containers, they are structural tools for building scalable, manageable, and presentation ready Liquid Galaxy visualization. If you have any questions or would like to discuss this topic further, feel free to ask in the community chat. I would be happy to respond and continue the discussion.